This problem asks us to write in terms of x and y. Tan of sine inverse x plus cos inverse y. In order to do this problem, we need to know a few things. So these are the prerequisites. First of all, we need to know the definitions of sine, cos, and tan as the ratio of sides in a right triangle. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And then if sine inverse x equals a, what that means is sine a will be equal to x. Now, you should also be able to write similar relations for cos inverse and tan inverse. So, in other words, if cos inverse x is a, then cos a will be x, and so on. And then we also need to know the sum and difference formulas for sine, cos, and tan. Now, if you know the sum formula, you can get the difference formula quite easily. So here are the sum formulas. Sine of a plus b is sine a cos b plus cos a sine b. Now, the difference would be sine of a minus b. In that case, it would be sine a cos b minus cos a sine b. And then cos of a plus b is cos a cos b minus sine a sine b. And cos of a minus b would then have a plus here. And tan of a plus b is given by this fraction, tan a plus tan b over 1 minus tan a tan b. Now tan of a minus b would have these signs changed. The plus becomes minus and the minus becomes plus. Alright, so with this, let's go ahead and try to write this. Now let's copy the problem. Tan of sine inverse x plus cos inverse y. Now each of these are some angles. So let's say this is angle A and this is angle B. So really we have to eventually find tan of A plus B. So we can use the sum rule for tan. Now notice, first thing we did is we wrote sine inverse x equals A, which means sine A is equal to x. And sine A equals x, x can be written as x over 1. We can always write as a fraction. And then we draw a right triangle with that information, which satisfies this equation. So right angle, and we want to call one of the acute angles as A. Then sine A is x over 1. And sine A is opposite. Opposite to A is this. So I'm going to call this as x and the hypotenuse as 1. Now once we figure out these two sides, the third side can be found from the Pythagorean theorem. So use the Pythagorean theorem. You square the hypotenuse and square the leg and then subtract. And then take the square root. So it's going to be 1 square root of 1 minus x square. So that's coming from writing sine inverse x equals A. We have this triangle. Now let's write this piece, cos inverse y equal to B. And what this means is cos B is equal to y. So just like before, we are going to draw a right triangle and we call one of the acute angles as B. So say this angle is B. And cos B is y, which is y over 1. And cos is adjacent over hypotenuse. So that means I want to write the adjacent to B, which is this leg, over 1. And hypotenuse is 1. So again, using the Pythagorean theorem, I can get this leg as square root of 1 minus y square. Awesome. Now, eventually we have to find tan of A plus B. So tan of A plus B is the fraction where the numerator is tan A plus tan B divided by 1 minus tan A tan B. and let's write it here. Now that we have these two triangles, we can tell what tan A and tan B are going to be. That's what's going to be used here. Tan is opposite over adjacent, so it's going to be x over square root of 1 minus x square, and tan B is square root of 1 minus y square divided by y. So this is our numerator. And now we have to write the denominator, which is 1 minus their product. So this is going to be x over square root of 1 minus x square times square root of 1 minus y square over y. All right, it's time to simplify the expression. So we have the numerator consists of these two fractions that have to be combined. So we can cross multiply. It's going to be xy plus, we multiply these two. So it's going to be square root of 1 minus x square, square root of 1 minus y square, and then the denominator is the product of the denominators, which is square root of 1 minus x square times y. And here again we can cross multiply. We get 1, you can write 1 as 1 over 1 if you want. So cross multiplying, you get square root of 1 minus x square times y minus 1 times this, which is x times square root of 1 minus y square, divided by the product of the denominators is square root of 1 minus x square times y. So the algebra is kind of messy, but you get the idea. Now notice we have a complex fraction and the denominators are the same, so we can get rid of that. So it turns out to be this quantity, xy plus square root of 1 minus x square, square root of 1 minus y square, divided by, let's write y first, y square root of 1 minus x square minus x root of 1 minus y square. So this is our final answer.